Our agenda today is to get familiar with Lean, evolution of Lean, getting familiar with Lean principles and different types of waste, and know what a Lean system comprises of. So what is Lean engineering? Although we have been hearing this word since few years now, we do not have a perfect or a good definition of Lean. Not everybody means the same while talking about Lean. So Lean focuses on eliminating non-value added steps and activities in a process. Lean makes sure we are working on right activities. Lean establishes the value flow as pulled by the customer. So from these, we could define it as a business system that connects and empowers employees to improve the value of products and services to customers by reducing waste and producing the correct quantities of desired products. So Lean systems are value chains that maximize value added at each operation by eliminating waste. So how did this all begin, the evolution of Lean? Well, in 1880s, Eli Whitney, who was mostly known for his invention of the cotton gin, popularized the idea of interchangeable paths. In 1909, Frank and Lillian Gilbert have conducted so many motion studies and more efficient processes of the manual processes that were going on during that period of time. In 1911, Frederick Taylor, who is considered the father of modern management science, he established the entire field of scientific management by measuring work and trying to improve efficiency. And then Henry Ford assembly plant begins with first Model T rolls off the line. Though Henry Ford was not the first one to use the assembly line, he was the first one who most consistently implemented this assembly line technically for a high-end product. And then in 1945, taking inspiration from Henry Ford, Taiichi Ono and Shigeru Shingo and others developed the Toyota production system, and it refines throughout the subsequent decades. They have been improving it on this Toyota production systems during all this time. And in 1975, Toyota production system came around, noted in all around the world. In 1980, Toyota becomes the world's leader in car production. In 1988, the Lean production was first coined by John Graffett, and then later on, James P. Womack in 1990 wrote a book, The Machine That Changed the World, which brought in the term Lean. So, breaking down the Lean principles, what are the principles that Lean uses for its implementation? The first and foremost important one is you have to specify the value in the eyes of the customer. So determine what value is in the customer's eyes. What does the customer want out of a product or service? A customer will not pay for waiting, transportation, rework, moving, and other things that the customer do not think or consider to be something that they should pay for. They might consider something like delivery, total cost of ownership, and data and information that is available through the product or service. The next thing is identify the value stream and eliminate waste. The value stream includes all of the activities, materials, people, information that must flow and come together to provide your customer the value they want and when they want and how they want. The third one is make value flow smoothly at the pull of the customer. So whenever a customer needs something, you have to pull it smoothly to the end of the customer from the start, beginning of the product. The fourth one is involve and align, empower employees. And the fifth one, continuously improve knowledge in pursuit of perfection. So when we're talking about value, we also have mentioned what is a waste. So let's see what are the wastes. In Toyota production systems, Taiichi Ono actually mentioned 7 kinds of waste, but we're going to discuss one extra kind of waste which has been coming into picture recently, which we'll discuss at the end of this one. So the first type of waste is overproduction. Manufacturing an item before it is needed. The waste of overproduction is producing too much at a given time. So overproduction may be characterized by producing more than what is needed, producing earlier than what the customer wants, and producing faster than it is needed. The second type of waste is inappropriate processing. So using bad tools for a particular kind of process is also kind of inappropriate processing. So all additional steps or activities involved in manufacturing processes are considered processing waste. Like you can see the guy doing a drill, which is not necessary there. The third one is waiting. Delays, idleness, line imbalances do not provide value to your product or service. So waiting is also a kind of waste. The fourth one is transportation. Excessive material movement and handling would give you this kind of waste. Most people in material handling would know double handling is a type of waste. So excessive transportation is one kind of waste. Motion. Efficiency in motions of all human operators is very important. All unneeded motions are wasteful. The workplace should be changed to fit the employee by redesigning tools to reduce stress and injury and practicing job rotation. The sixth type of waste is inventory. Anything that is extra in your plant or your facility is your inventory and naturally occupies space in your facility, which obviously increases costs. So excessive unnecessary inventory increases costs. The seventh one is defects. Rework and scrap adds costs like lost capacity, opportunity costs, increased inspections, rescheduling efforts, loss of customer goodwill. The eighth one that we were about to discuss, which is quite new, is underutilization of employees. So if a worker potential is not utilized to their potential, then it is a waste, which is recently been considered as one of the waste and added to the 7 types of waste that what Taiichi Ohno gave us. But the most important thing to remember about waste is that it is a symptom rather than root cause of any problem. It points out to problems within the system at both process and value stream levels. We need to find and address the causes of waste. This is actually a good place to start to implement lean in your company. Toyota production systems. So Toyota's production system is one of the most admired lean manufacturing systems in the world. They have ingrained culture of continuous improvement. Employees are all encouraged to experiment to find better ways to do their jobs. Work is completely specified as to content, sequencing, timing, and outcome. Services and goods do not flow to the next available person or machine, but to a specific person or machine. Improvements to the system must be made under the guidance of a teacher at the lowest possible organization level. Employees who are actually doing the work are actively involved in making improvements. So the employees are involved in making improvements, so which gives you more opportunity to know the problems better. Central to the TPS is a continuing effort to produce products under ideal conditions. Sub-assemblies are transferred to the assembly line on a just-in-time basis, which we're going to discuss in a little while. High quality and low assembly time per vehicle. TPS emphasizes on continuous improvement, respect for people, and standard work practices, which are the pillars of Toyota production system. Lean production supplies the customer with exact wants when the customer wants it without waste. So the employees, all the employees in Toyota production system or in Toyota plants have 2 jobs. They have to do work and improve work. The first 3 principles covers the do work aspect of these employees, and the last 2 principles like worker empowerment and continuous improvement comprise of improving work, improving your own work at the site. So how do you know if your company is marching towards lean, or how do you say a facility is marching towards lean? So these are some of the characteristics of lean which would tell you if your system is going through lean or not. So a lean system always minimizes costs and waste. So if you minimize the waste, you have reduced costs. It reduces minimizes the inventory levels in your facility. It uses pull method of production, which we'll discuss in quite a while. It uses small lot sizes, short setup times. It has high quality, uses total quality management principles, balanced workloads, line balancing. It also has standardization of work methods and paths. It has flexible workforce. Most of the high-ended plans or production plans would go to automation, which improves the efficiency, and has small capacity cushions. There are no buffers in a lean system, ideally. And they have close relationships with the suppliers so that they can get the product whenever they need. Other than lean, Are there any different kind of production systems in different companies? Yes, there are different kinds of production systems, but they all strive to achieve the same principles. Different companies use different names, like stockless production in Hewlett-Packard, materials as needed in Harley-Davidson, continuous flow manufacturing in IBM, and just-in-time manufacturing is a generic lean term that has been used in different companies. So what are push systems? Push systems are where the raw materials and parts are planned, scheduled, and acquired prior to the production. Materials and parts are pushed into production operation before it starts. All materials needed for a production run are gathered. This creates excessive and unnecessary inventory, raw materials, and work in process. Thus, it increases excessive inventory costs. Pull system. Lean systems are pull systems. Parts and materials are requested and delivered as they needed. Materials and parts are pulled into the production operation as they need. They arrive just in time to be used in production processes as in a Ford assembly plant. But the real difference between a push system and pull system is that a pull system is the one where you can explicitly limit the work in process in your system. Just-in-time systems. Just-in-time is a generic term for lean production systems. It utilizes pull system of production, attempts to minimize inventory, is highly dependent on supply chain efficiency, and requires the supplier must deliver what you need and when you need it. Just-in-time is just enough of materials needed for operation arrive when and where they are needed. The results of just-in-times are reduced inventory, especially work-in-process inventory. The goal of just-in-time would be to smooth the lean production process to a point where only minimal inventory is required. Setup times. Setup costs are the costs of changing a production line from making one type of product to making a different type of product. Changing machine programming, dies, and generally getting the production line reconfigured are some of the examples of some of the setups. Setup time refers to time it takes to change the line for the next production run. In terms of healthcare, setting up a room or a surgery room for the next surgery is kind of one setup that healthcare. Just-in-time requires low setup costs and times. So short setup times is the main aim of just-in-time. Small lot sizes require more frequent setups. So if you have to do 20 setups per day, you must be able to do them quickly and cheaply to reduce the idleness of machinery and people. The longer the setup time, the more you need to produce. That means you have a lot of a big lot size to justify the setup time. A big lot size means more area and more volume of your product occupying the floor space. The Japanese, one of the example is that the Japanese goal for setting up dies in their plants is using single minute exchange of dies, SMED. If you have listened to it, this is a tool of lean manufacturing. The other thing that is necessary to carry out lean operations is steady demand and worker empowerment. Steady and predictable demand is necessary. Just-in-time and small lot sizes require smooth production schedules. If demand is uncertain and variable, it usually requires higher capacity cushion, that means buffers. Lean does not allow ideally inventory buffers and it defeats the purpose of just-in-time. Expanded worker and supervision involvement. Responsibility for the coordination and scheduling of material flows shift downwards to the workers and the supervisors. Small inventory buffers don't allow for staff and upper management to get involved. So, worker empowerment is needed for fast and on-spot decision making. So this is why worker empowerment is one of the principles of lean. The other necessary aspect for conducting a lean system is reliable vendors and reliable equipment. Vendors must be located close to the plant in order to have a lean system. And they enable frequent deliveries of small quantities. Inventories of a few hours are not unusual when you have vendors located close to the plant. Reliable production equipment is needed. Equipment failure halts production, so we need really reliable equipment, especially in a lean system. Lean systems don't have extra inventory to buffer the operating workstations. So there's a famous proverb that says, chefs cover their mistakes with sauce, lawyers cover their mistakes with paper, architects cover their mistake with ivy, doctors cover their mistakes with salt, and industrial engineer covers their mistake of system design with buffers. So if you see a large amount of buffers, that means there's something wrong with the system. The another important aspect of having a lean system is having total quality management. Total quality management is necessary for the products can stop a production line or process that uses a lean system approach, because you don't have buffers and there are small lot sizes and there is single piece flow in a lean system. One defective product could stop the entire line. Workers are the quality control inspectors, so we have quality control at the station. Thus, quality is control at the source. Instead of having a quality at the end of the line, we have the quality at the spot of the station, so that there is more scope to eliminate the bad parts. This minimizes scrap and rework, thus reducing WIP and cycle time. TQM promotes consistently high quality and continuous improvement efforts. The most important aspect would be supplier relationships. So in order to have a lean system or a just-in-time system, we need to have good supplier relationships to have whatever material is needed on time. So small lot sizes require frequent, reliable deliveries by local suppliers. If suppliers are not reliable, you cannot have just-in-time. Nearby suppliers and frequent deliveries reduce the need for safety stock and thus lower inventory costs. Firms converting to lean systems generally make a drastic reduction in number of suppliers. A cooperative approach with suppliers is essential to ensure reliable on-time deliveries and consistent quality. The final but the most important part of having a lean system is striving for continuous improvement. One of the philosophies behind lean systems is to uncover problems, learn from them, and solve them. It is a continual process. No production operation has a lot size of 1 or 0 setup times. But these are the goals to continuously strive for and achieve minimal lot sizes and minimal setup times. The result is, however, is focus on continual improvement. Kanban. Kanban is a Japanese word that is used for signal calling cards. A Kanban is a signboard or a placard used to signal for more material, or if there is empty container at the line, it has to go back to the marketplace. A JIT system used by Toyota, it's a just-in-time system used by Toyota. Two-card visually coordinated JIT system. There are withdrawal cards and production order cards. The withdrawal cards are used to send back the empties, and the production order cards are used to bring in the full containers to the line. The Kanban system works well in repetitive production environments like line flows and product flows if you're able to achieve small lot sizes and short setup times. Line balancing. Line balancing at workstation is very critical. Imbalanced production lines creates excessive work in process, longer cycle times, and balanced days. For example, if a capacity of a machine downstream is less than the capacity of it producing just before that machine, then you see a lot of inventory between these two machines. There is a blockage, and that machine creates a bottleneck for your entire process. So the lines must be balanced, and equal capacities at each workstation has to be ensured, and these bottlenecks must be eliminated. So in summary, in order to have a lean system, you will need a cooperative relationship with close suppliers who make frequent deliveries, a pull system of production that emphasizes automation, standardization, TQM balanced lines, small lot sizes, and short setup times. You need steady and predictable demand in order to implement lean, job enrichment and empowerment for the workers. So the workers must be able to take decisions on the spot. A culture of learning and continuous improvement is necessary in order to help achieve the goals. So in summary, we can say that lean production combines the advantage of craft and mass production, avoids high cost of craft productions, avoids rigidity of craft productions. It focuses on perfection, zero defects, zero inventories, and has endless product varieties, highly flexible, increasingly automated machines. A lean production system has multi-skilled workers. They utilize less resources compared to mass production. They have the human effort and with half the space and inventory and half the investment tools. So these are some of the lean elements that could be a part of your lean system. Not all elements would be applicable in all kinds of industries, but these are some of them which can be applied to most of the industries. So Kanban system, one-piece flow, level scheduling, reduction of lead time, reduction of lot sizes, small single-minute exchange of dice, multifunctional workers, equipment layout, TPM, standard operating procedures, poker yoke, reliable suppliers, and all of these are Kaizen, and all of these are some of the lean elements.